In the past videos, we have been looking at acids, alkalis and bases. We should know by now that acids and bases can neutralise each other, and that alkalis are a type of base. We are going to try and understand these in a little bit more detail. Bases are metal oxides and insoluble hydroxides. Alkalis are soluble hydroxides, for example sodium hydroxide. Acids are substances which donate H+ ions. We are going to look at these in more detail in just a moment. Finally, a neutral solution is water. When a solution is formed, it will either be acidic, alkaline or neutral. We need to look at acids a bit further. If we add an acid to water, something happens to the hydrogen. It is released as an ion. So, in water, hydrochloric acid will form a H+ ion and a Cl- ion. The H+ ion makes the solution acidic. A similar effect happens when an alkali is put into water. However, in this case, an OH- ion is released, not a H+ ion. So when sodium hydroxide is added to the water, we get a solution of OH- ions and Na+ ions. The OH- ion makes the solution alkaline. When an acid is added to an alkali, the H+ ions react with OH- ions to form water. This is why we say they are neutralised. The pH scale is used to measure how acidic or alkaline a solution is. The scale goes from 0, which is the strongest acid, to 14, which is the strongest alkaline. 7 is the pH of water, and hence it is neutral. Universal indicator can be used to measure the pH of a solution. It turns to the specific colour associated with that pH. We are now moving on to strong and weak acids, so the rest of this video is now higher tier content. In the last section, we discussed how acids will produce H+ ions in water. This reaction isn't as simple as it first seems. Sometimes the process is reversible. So, when some acids are placed into the water, the H+ ions are formed, but also these ions can combine with a negative ion from the acid to reform the acid molecule. When the ions can reform the original molecule, the acid is known as a weak acid. In weak acids, an equilibrium is set up where there is a small proportion of H+ ions, and this explains why they are called weak acids. This equation shows propanoic acid producing propanoate ions and hydrogen ions in a reversible reaction. When the acid completely ionises in water, the acid is a strong acid, since there are lots of H+ ions present. Hydrochloric acid is a strong acid, while any carboxylic acid is a weak acid. You also need to be aware of the terms concentrated acid and dilute acid. When an acid is diluted, more water is added to the solution, so that the acid molecules are less concentrated. If we have 2 beakers of water, of 1 decimeter cubed each, and add 1 mole of strong acid to one, and 2 moles of weak acid to the other, the second beaker is the most concentrated acid solution, regardless of it being the weak acid. Concentration is different to strong or weak. You can have a concentrated, weak or strong acid. We are now going to look at the pH scale. If we have an acid of concentration 0.01 mole per decimeter cubed, then the pH of the solution will be 2. If we have another solution of 0.001 mole per decimeter cubed, then the pH will be 3, and so on. This is because, as the pH value increases by 1, the concentration of H+ ions must decrease by a factor of 10. This makes sense, as the lower the H+ ion concentration, the less acidic the solution is.